LPP, it involves, whenever we are talking about the LPP, we are talking about the number of variables. So if we have two unknowns, it can be solved by using these two methods. Graphical method, trial error method, which is also known as search approach method. This is also known as algebraic method. Fine. But trial error, algebraic, all these are same name. Means these are one method. This is one method called by these names. It can be solved for two variable also. It can be solved for more variables also. Means, but maximum we go till 10th to till 15 and sometimes 20, but it is very, very tiring. It requires a lot of computational work. So it is not suggested. Till 10th, it is okay. But if we have 3 or more number of variables, then we apply these methods. Simplex method. Next, we have two-phase method, big M method, dual method, dual simplex method, simplex. Then we have a revised simplex. This all we'll do with time. Today we are starting with this one. All right. So let's start. Take your class. So in the LPP, we have two or more variables. And three or more variables. So here we have graphical and algebraic or trial and error or so in the graphical, again, it helps us to find the optimal solution using feasible region. Feasible region, which is when I write fast, it won't write. The stylus. Okay. Then we have here, we use the cases or combinations of variables. Combination of variables. Here we have simplex and methods using simplex. Various other methods using simplex. So all those which I told you earlier, all these are this one, this one. All these are derived from simplex. All these are derived from simplex only. Not much, no much difference. All right. So first we are starting with this one. Now, before you start this, it's very, very simple. Very first thing you need to remember, first you identify your problem. Then you need to solve your question step by step. That is, you find your decision variables, how many decision variables you have, what is your objective function, what are your restrictions, which means you need to formulate your problem. First, you identify all these things. Then step 2, formulate LPP or model, mathematical model. Once you have done this, then we plot graph for all constraints. Then identify feasible region, which means now this feasible region means what? This is going to be my solution space. Means my solution would be lying somewhere here only, which means it is the intersection. Which means it is the intersection of all the region made by the constraints. I'm writing the shortcut. intersection of all the constraints. And since you know your restriction means it is strictly greater than equals to 0, therefore it would lie, means feasible region lies only in first constraint, first quadrant. Okay, this you already know. After this, now what would be my step 4? When we have plotted this, now the region which we have attained, now region could be my bounded region and this could be unbounded also. Unbounded also. Then what you need? You need to find your coordinates. Compute the coordinates of all the corner points. We need all the corner points of the feasible region. The feasible region. Done? Now, after this, when we have received our corner points, then what you need? You need to find the value of objective function. Find the value of objective function. Where? At each corner point which you have received in step 4. At each corner point from step 4. Now, where is my cursor? Okay. Step 6. Now, what you will do? Select the corner point. Which corner point? That optimizes. Now, optimizes means optimizes, which means either maxima or minima as per our given LPP. If it is maxima, then we'll need the maximum value which we are getting at the corner point. If it is minimization problem, we'll find the minimum value of the corner point. So that optimizes maximum minimum. That is the objective function value. Objective function value will give optimum feasible solution. Understood? Now, let me rewind. Very first step, what you have to do, first you identify all your decision variables, which means what we are looking for, x1, x2, x3, whatever as per your given formulated problem. What is your objective? I need the minimization problem or it is a maximization problem. So restriction has to be always greater than equals to 0. You have formulated your model. Now I need to plot. How we are going to plot? Say suppose I have 4 constraints, 4 simultaneous equations, which are my 4 constraints. Then you need to plot all these lines, all these constraints. So your one constraint is going to give you one line, another constraint will form the another line. So ultimately, when you have plotted all your constraints, we will have some intersecting points and we will have some shaded region which would be the intersection of all these constraints. And we are only looking in the first quadrant because our restriction is telling that every variable is strictly greater than equals to 0. So our solution region lies in first quadrant. Now my region could be bounded and unbounded. So based on this, you will try to find all the possible corner points of the feasible region. Once you have received all your corner points, then what you need? You find the value of objective function at each corner point. Evaluate it, you keep it aside. Now you look your LPP, it is maximum or it is minimization problem. So based on that, if it is maximization, so out of all those evaluated objective function value for the corresponding corner points, you select the maximum one. So that is going to your optimum feasible solution. And if it is of minimization, select the minimum one. That is my optimum feasible solution. Clear the method? So my problem here is, suppose it is asking maximize set 3000x1, 2000x2, subject to the constraint 5x1 plus 2x2 less than equals to 180, 3x1, 3x2 less than equals to 135, x1 and x2 are greater than equals to 0. Okay, solve graphically. They will tell you, okay, how you have to solve it, because it is a LPP. So every problem will be of this form only. But which method you need to apply, they will tell you. So it is telling solve graphically, then only you are going to apply the graphical method. Fine. So now you recall your first step. Our first step is you identify decision variable, objective function, restriction. So according to step 1, your decision variables are, tell me side by side, everyone. Hurry up. So here we need our decision variable, then we need objective function and the restriction. Objective function and then we need the restrictions. Okay. So you tell me, what are your decision variable here? Hurry up. Everyone knows this. This is your given problem. So what you are looking for? You have to solve graphically. So when you are solving graphically, what you are evaluating? Tell me fast. Anyone? You see, 64 students are sitting here. Reply fast. What are your decision variable here? X1, X2. Yes, Aditi. Yes, this is what I'm asking. Don't waste time, no? Hurry up. Objective function here is, write your objective function. Your objective function here is, whatever is your Z or Z, it is 3000 X1, 2000 X2. Now what are your restrictions here? It is already given. Your decision variables are strictly greater than equals to 0. Step 1 done. Now you need the formulation. So it is already given in the formulation form. So it is already done. Means given. Mention it there. Now I need my step 3. Now we need to plot the graph. Plot the graph for constraints. So now you see how we are going to plot this. How many constraints are given? How many constraints are given here? We have, this is your objective function. So these are 2 constraints. So whenever you are given 2 constraints, whenever you are given the constraint, you see here we are given inequality. So whenever inequality is given, doesn't matter, we just change it into equality as it is. So our given constraints are 5x1, 2x2, which is equals to 180. And another is 3x1 plus 3x2, 135. So we'll solve it like this. So these are your given constraint. How you are going to do? Let me take this on that side. Yes, we have space here, that is why. It is 3x1, 3x2, 135. How we are going to solve? We have 2 variables. What we do? Put first variable equals to 0, get the value of the other one. Then you put the another variable equals to 0, get the value of the other one. So here I have taken x1 equals to 0. Then what will be the value of x2? You tell me. Now put x2 equals to 0. That's it. Then you put x2 equals to 0. Get me the value of x1. Tell me. Yes, good. So my x2 here is 90 and my x1 here is 36, which means my coordinates here are what? 0 and 90. Here I have 36 and 0. Good. Who is that? Amit and Bhav. Next, similarly, give me the points for this constraint. Now put x1 equals to 0. Find the value of x2. Then you put x2 equals to 0. Find the value of x1. Very good, Bhav. Anyone else who have got the value? So here we are getting 45 and x1 is again 45. So your coordinates here are 0 and 45 and 45. Good. Yes, Amit. Correct. Fine. Now we have received our, we had two constraints. This is our constraint 1, constraint 2, and we have received our corner points. So our step 3 is done. See here again. Identify problem done. Formulation already given. Plot the graph since the constraint were given. So we have found our points. Now what we need? The intersecting point, which means we have to plot it. So now you plot this. Let's plot. Okay. X, Y. It is going till 90. So let me take 10, 20, 30, 40, 50, 60, 70, 80, 90. Fine. So I have here 0 and 90. So 0 and 90, okay, 10, 20, 30, 40, 50. Let it be somewhere here. 90. Suppose this is my point, which is 0, 90. Then it is going till 36 and 0. Where is my 30? 30 is here, 35 is here, somewhere here. So this is my 36. Let's join. Okay. Somewhat like this. Okay. Then I have another one, 0, 45. So my 0, 45, 10 minutes, 10, 20, 30, 40, 0, 45. Then 45, 40 here, 45. Join it. See, somewhat like this, because this is my stylus, I'm not on board. So somewhat like this. So I'm getting one intersecting point here. So let's name it. If I take this as O, let it be A. Origin. Let me name this as B. Let it be my C. Let it be D. Okay. So I have 1, 2, 3, and this will be my 0 and 0. So I need the value of this T point. For that, what you will do? Solve simultaneously. Firstly, you see your region. What is your intersecting points? Now this is my line. This is my first quadrant. So which means this would go here. This is my another line. Again, I need only the first quadrant. So every region below this line. So the feasible region which I am feasible matlab where my solution would lie, that would be this region. Pretty obvious. So where are my corner points? I have one corner, another corner, another corner, another corner. So our next step tells what you need. My region here is bounded. We have received 4 corner and it is covered. So corner point we have received now. Now I need the value of objective function at each corner point. Okay. So, but my one corner is still missing. I have this point 0, 45. I have this point 0, 0. It is this one 36, 0. But this point I need to evaluate. So how you are going to evaluate this? You solve your equation simultaneously. So for point D, suppose I'm writing here only. For your point T, My equations are 5x1, 2x2, 180. Other one is 3x1, 3x2, 135. Now you solve this simultaneously. Anyone has done? So when you solve this simultaneously, you will get the value. How much time is left? 7 minutes left. So I guess you can do this. Anyone? Okay. Solve simultaneously. Get me the value of x1 and x2. Fast. Just take 1 minute. It will take 1 minute only. And this is 15. So our coordinate here is 30, 15. Very good, everyone. Those who have found the answer. Now what you need? Our step 5. It says we need the value of objective function at each corner. So now we have 4 corners. 1, 2, 3 and 4. So we need value of objective function z1, z2, z3, z4. And your z here is this 3000 x1 plus 2000 x2. So when we'll find this value, say suppose my z1 here we are taking 0.45. Point. Wait, let me complete this question first. Let me complete this. So my this point here is 0.45. So when you put this value in your objective function, you will get this value. Now, say suppose my b here is this. We are getting straight away 0. Next point is 36, 0, 108. This. And your next point here is 30, 15. We are getting here 1, 2, 3, 4. So which one is the highest one here? Which one is the highest value here? Wait, I'll tell you. Which one is the highest one here? Z4. Z4. You see again. This is our value. 9,000, 0, 1 lakh, 8,000, 1 lakh, 20,000. This one is greater. Where we are getting at this point. Therefore, your objective function value is 1 lakh 20,000 and feasible point, basic feasible point or solution, it is 30, 15. Clear? Now you tell me who was asking. I'll explain the points. I didn't get the right answer solving simultaneously. All right. Who is this? Thinly. You see here. This is your equation. You need to solve simultaneously. What you will do? Suppose I first eliminate my variable. I want to eliminate my x2. All right. So I'll multiply with 3. I'll multiply with 2. So what you will get? 15x1, 6x2, 5. Then 2, 3, 6, 6x2, 270. Now you subtract it. So you will have 9x1, 270. X1 is your 30 here. Therefore, now you put in any of the equation, you will get the value of x2 is 50. Okay. Got it now? Who is this? Z3. Who is saying Z3? It's not Z3, Sarah. Our objective function is 3000 and 2000. Okay. And our point is this. Z4. Fine. Everyone clear? Anyone is having any doubt? I guess. So let me write one more question so that even if we are not able to complete it, you can try yourself. Let me write one more. Good, fine. Okay, so our next is, it is asking solve graphically. Maximize z, 3x1, 4x2, subject to the constraint x1 plus x2 less than equals to 450, 2x1 plus x2 less than equals to 600, and your x1, x2 are greater than 0. So straight away, you see, here your decision variables are x1, x2, objective function is this one, and your restrictions are all greater than equals to 0. Fine. So formulation is already done. So this is your step 1. Formulation is already done. Step 2. So in step 3, we need to plot directly. So now you plot it. So here equations are x1 plus x2 equals to 450, 2x1 plus x2 equals to 600. So once for this, when I am putting x1 equals to 0, so straight away my x2 is 450. When I am putting x2 equals to 0, so straight away my x1 here is 450. So my points are 0, 450, 450 and 0. Clear? Then from here, now put x1 equals to 0. So here x1 is 0. So your x2 is 600. Now if my x2 is 0, so your x1 is 300. So your points are 0, 600, 300